Hello and welcome to today's video. So on the workbench today, the Pack Sniffer 2. And yes, I know, it's been a long time coming. It's taken a lot longer than I thought it would to actually, work on my other projects and try to find time to get this done. But I do receive a lot of questions, a lot of emails of people asking for Pack Sniffer 1s, and I was like, well, if I'm going to do a new one, if I'm going to do another run, because I originally built 6, and I only had 6 boards, and I sold all of those. And it was one of those, well, if I'm going to do another run, I might as well incorporate a lot of the features that people have been requesting. So I went out on DIY and electric car list and asked for features and things like that people requested. And I got some feedback and went ahead and incorporated all that. So thus, Pack Sniffer 2. So if you've watched my channel, watched some of the videos, you would have seen me working on the schematic, layout, and everything. Ordered all the parts, got all those in, and I built it up. And this is it. So I've got 6 boards again. One is fully built up. I had one mistake, not too terrible, easily fixed, but I forgot all of the flyback diodes on the outbits. So all the sync and source drivers are lacking flyback diodes, which you need if you're going to be controlling contactors or relays and things like that. You definitely want those on there so the high voltage inductive spike doesn't pop your MOSFETs. The one here that I built up fully, you can see I've added some diodes in there. There's also some inside there and some over here. So that allows it to survive that, and I'll go ahead and put that on all these other ones. It's not worth, it's such a small thing that it's not worth like respinning the boards just for that. So I'll probably just solder them on there on these guys, maybe put some Celastic or epoxy or silicone on them just to give them some stability. And yeah, we'll call that good. So there is one mistake. So if you see those soldered on there, yeah, that's for that. So yeah, a lot of the features that people were requesting were, well, mainly dual CAN bus seemed to be really high on the feature list. So the Pack Sniffer 2 has 2 CAN buses. That was pretty easy to implement because my microcontroller has 2 CAN modules built into it, and it's pretty easy to drop a couple CAN transceivers on here. One is there, and then the other one is in the middle there, right there. A little 8-pin package. 8-pin SOT23 package. But yeah, so now they have dual. Well, actually, let me just go over like the connectors here. So the 14-pin connector on this side has 2 source outbits, 4 sync outbits, 2 A to D inputs, and then of course CAN bus. And then if we go to the 10-pin connector, that has 1 source outbit, which is 12 volts, 3 sync outbits, and then CAN bus and RS-232 actual serial RS-232 levels. There is a like a max 232 chip equivalent here to convert the 3.3 up to I think it's a voltage tripler, so plus and minus 9 for doing actual RS-232. It's not UART. So we got that on there, and the main feature request was definitely dual CAN buses. Oh, and if I didn't mention, there's a microSD card and a micro USB. I'll show the microSD card, the bootloader, running here in a little bit on this board. Yeah, so the main request was dual CAN buses, and that has to do with the way CAN buses, like the baud rate's not really standardized. So you might end up with a battery pack talking at, say, 500 kbaud, and then a battery charger talking at 250 kbaud, or they're different baud rates. And so the other problem is that the Nissan Leaf battery pack, you can't change the CAN packets that it spits out if you're using the stock one. If you're using my modified one, then yeah, it can be changed because I have control over that. But the stock one, it can't talk to your battery charger because it wasn't designed to do that. So this can do that translation for you. So it can take in CAN message from the thing and then spit that data over to the battery charger, so it knows when to shut down, or it can communicate that over to the battery charger. So that's just an added like benefit of having the 2 CAN buses. Another thing is you might have two identical items on the same CAN bus, and that doesn't work very well if they have the same CAN messages and they're not, you can't change them. So you might have two Nissan Leaf battery packs. This way you can put one on this bus and one on this bus. And to translate it, you can either, bump them up. So like if it sends a message on like 2B0, now it's like sends it over on the other one at 2C0. So you can see everything on one side, or vice versa. So it can level shift, but like address shift, I guess is what you would call that. CAN bus address shifting. Yeah, sure. That's a thing. And the other thing you could do is, it could just read both without doing any shifting and just display everything on here. But yeah, so it can do that. Then I also had requests for serial. Some battery chargers are RS-232, and that way this can talk to that and shut it down and do its thing when the battery pack becomes fully charged. Either side can handle a Nissan Leaf battery pack, including controlling the contactors, pre-charge, and ignition. So there's like a 12 volt, that's what that 12 volt source on both sides is for, that to simulate you giving it power, the ignition, so that it can be power cycled. Yeah, I think, the analog inputs on here, this is one request that I didn't think about. People want to put this in their vehicle as a little display in the corner, and tell you the voltages and current and stuff like that from the battery. And one of the things they wanted was the display to be dimmable. And so there is a MOSFET on here that controls, that's this one right here, that controls the backlight on the display. PWM's the LED backlight, and that can be controlled by one of the analog inputs so that you can have dimming. So 0 to 12 volts or 13 point, whatever it measures it, and then it scales it. So 0 to that will do the PWM dimming to the backlight, so that your little dimmer knob on your car can just be wired right over and it'll work perfectly fine. If you've got CAN bus dimming, then it can read that CAN packet and adjust the PWM value to the backlight. It can do that too. I just need to know what it is, what the values mean. But yeah, I think, is that everything? Yeah. So we've got the micro SD card slot on here, which is very useful. I got the bootloader running, so I'm gonna go ahead and demonstrate that really quick here. I can show you what that does on this guy that's hooked up here. So this one's fully built, what I would consider a production prototype now, and we'll go ahead and turn it on, and you'll see that we go in there and we didn't find an SD card because it's not plugged in. So it's just going to sit here and wait, and that's all it's going to do, because there's no application on it. So this one is completely blank. Like, the microcontroller has no code stored in it in the primary flash. Auxiliary flash is where the bootloader exists, and that's got all the information it needs to talk to the microSD card, to get the boost converter up and running, run the A to D to close the loop on that, and all the usual stuff. So we got all that working. So I just happen to have a little 8 gig, a giant 8 gig, although I think max would be like 32 gig. But that's another thing. We could do data logging. We could log the battery pack as it's charging, all the individual cells, like every second or something, to a comma separated file if you wanted to watch all the little plots of all your cells. Yeah, lots of space on these. I love these little micro SD cards. We are talking to it over SPI, so we're not super fast, but it gets the job done. Let me go ahead and see if I can get this in here. So when I plug this in, what's going to happen? It's not in all the way. So what's going to happen is it's going to it's going to detect that I plugged it in. It's going to then read it over SPI, scan it, find a firmware file, latest firmware file on there. It's going to then calculate the checksum of that firmware file. It's going to go calculate the checksum of program memory, which is empty right now. It's going to say, oh, those aren't the same, so I'm going to copy that firmware from here, the .hex file, onto the micro, and then after that's verified, it's going to read it and make sure that it verifies that what is on here matches what's in the micro. Then it'll jump execution to primary flash, and it'll run the application. Now, my application isn't that amazing, but we'll see what happens here. We'll plug it in. We found version 1.0, and you saw they were different, and this is my application. So it is literally just running the boost converter and updating display. So we're taking 5 volts in from here at 250 milliamps. There is a current sensor, and we're boost converting it to 12. So the loop is just trying to maintain 12 volts. And that 12 volts is powering the display. I actually take 5 volts in, boost convert it, then regulate it back down to 5, which seems odd, but that actually... you notice my other one, when you would turn it on and off, sometimes the display wouldn't come on, and that was because there was so much sag on here. It was dropping down below 4.5 volts, at which point the display would stop functioning. So it didn't like it got in some weird latched up condition. You had to do it again to get it, because there was still some charge on the caps, and that would help it out, and then it would be okay. So anyways, what we're doing is this can drop down like super low now, and I'll boost convert up to 12, which will power the BMS, the contactors, everything. And then the 5 volts that gets regulated runs the display, and then that gets regulated down to 3.3 to run the micro and SD card and everything else, I think, and the RS-232. But that works really well. I haven't had any problems with that now. This also allows you to apply 12 volts externally to either of these connectors. These connectors also have a couple powers and grounds on them. So you can supply power either direction from either connector, and that will, if there's 12 volts found, it'll bypass the boost converter and won't even turn it on, which is useful if you're running it in an automotive environment. You can just wire that directly into your car, and then, or the 12 volt battery or DC-DC converter. And you don't have to worry about the 5 volt boost converter. That's just a holdover from Pack Sniffer 1, so you could take this out in the field off one of these little battery packs and hook up to your Nissan Leaf battery pack and sniff it, and then get all the cells, the high and low and state of charge, and see how good the battery pack is before you buy it. If you're not buying it on eBay, you can do that. But anyways, so we're now running the main application. We got SD card. So if I go ahead and power cycle it again here, so turn it off, and I'll go ahead and turn it back on. You'll see it comes up, it finds it, and found the file, but you saw both checksums matched, so now it just jumps right to the application, did anything. Now, for some reason, I didn't have my SD card in there now, because the bootloader has already copied it to main flash, so if I power cycle it now, it said it didn't find an SD card, but it had an application to jump to, so it just jumped to the application. Yeah, I'll replace the application with like the actual Pack Sniffer 1 code. That'll be the first code available on the website. Will just be Pack Sniffer 1, like version 1.0. We'll just replicate what Pack Sniffer 1 did. I do have to convert it over, port it over, because the pinout on the micro changed a bunch. So I need to not really rewrite it, but just kind of change all the I/O on it, get that working. But anyways, I'll go ahead and do that, and then when new updates become available, you just copy them onto the SD card. Eventually, I will have it to where you can do USB. You plug it in, it'll see the SD card that's plugged in as if it's a USB drive, and then you can just drop the files into the firmware directory. That'll be really neat. I don't have that working yet. Technically, the bootloader is not quite 100% done. It works, but I have no error messages. I would like to have all the fat file system errors pop up on here, instead of saying like error code 12. It should say like file not found, So I need to work on that, but I ran out of space. Let me show you what I mean here. Let me grab this. I'll come over here to the PC here, to my compiler, and you'll see down here I'm at 100%. I literally have 2 instructions left, 2 words of program space, and that's it. My I'm using auxiliary flash for the bootloader, which is only 24K of flash, only 24K. Primary flash is actually 256K, and the app that I'm running right now with the low boost converter takes up like less than 1%. But I am running a lot in here. I've got you can see I've got the ADC converter running, boost converter running, bootloader itself. This delay is for the LCD. Otherwise, you can't see anything. It just it flashes by so fast you don't see it. So I actually have some artificial delays in there to do that. Fat file system itself, I'm using FATFS, and then the code to run the LCD, and then of course my main. And then non-volatile memory is actually the code to write to program flash. And then the SD card is the SPI interface to talk to it. Traps.c is actually not compiled when you're in, that's only used for debugging, and that's to catch address errors and things like that. It'll just hold it so you can stay in the debugger instead of having the micro reset. So don't worry about that. But yeah, you can see my little, all these little messages take up a lot of space. That takes up like a bunch of program words. It's not too bad every 3, because a program word is actually 24 bits, so it's 3 bytes. Yeah, 3 bytes. So, you know, that would WOL only takes up 1 program word. So you can see I'm going to need a few more to be able to store all of the error messages I need to do. There's like 20 error messages in the FAT file system. I would like to have those actually displayed. I do actually want to set up the all of those errors. Just to have the bootloader complete and finished. So I got to go through and I'll find some more room and compress things down and transfer things and make new functions and stuff like that. So it shouldn't be too horrible bad. I think I can get it all in there. I just don't want to. I want to refrain from having to write a bootloader. So I'd have to like transfer execution, like have an application that is actually a bootloader. Because I don't know quite how I would do that. Maybe store the bootloader inside of the program so that it would jump execution to the main, to programming, to main primary flash, and then program the auxiliary flash, and then transfer execution back. Yeah, that would be really weird. So a bootloader would be difficult to write. So I want to avoid doing that. It can be done, because I don't want to write it. It'll take a lot of time, I think. Take a lot of experimentation. But anyways, so, oh yeah, you know what? I can show you how, like right now, so I've got one of these little micro SD card adapter things. So if I were to actually take the 8 gig card that we were using and stick that in there, we'll go ahead and put that in the side of the PC here, my laptop, and open it up. I named it Wolftronics. So you can see it's just a firmware directory with a file on it. That's literally it. So the bootloader knows to look in the firmware directory for this style of file name. And if I were to copy this and paste it, so let's just call it, let's say 1.9. Sure. It's new 1.9, so we can leave it in there. It'll automatically find it that it's the latest version. So we just kill that. Take our card out of here and slide over here and go ahead and eject that. And maybe if we're really close, if we're really lucky, I can get this in here one try. Nope, I missed. Okay, we're gonna cheat and do this. There you go, got it in there. Okay, good. So now, if we power cycle it, it'll find that our code is version 1.9. Oh, I found 1.9. Oh, but the checksums are the same, so yeah, it's not going to do anything. Oh, yeah. It wouldn't copy it because it was identical. So yeah, the file name doesn't really, that just lets it know which one's the latest, but it doesn't actually change the checksum. So, but it's just the hex file that MPLAB spits out. So you just name it that, and then it's ready to go. You can load it on there. But yeah, I think that covers everything. So yeah, progress is being made. Not quite ready to sell them yet. Still got to make a case. That'll be interesting. Yeah. But get the cases done and put all the little missing flyback diodes on there. Get that up and running. Finish the bootloader, and yeah, I think it'll be ready to go then. And then for all of you Jersey lovers, she's down here sleeping. Oh, she woke up. She's in her little cubby hole down in here, underneath the workbench. She was sleeping. But anyways, yeah, that is the Pack Sniffer 2. Thanks for watching.